Hi, everyone. Today we're going to talk about removing complexity from integration tests with Testcontainers, which is a great family of libraries. Back when the computers were large, the phones came with buttons in them, and when bolt was a thing that you like screw a nut on and fasten things together, we had an understanding how we want to do tests, right? To have solid software, to have reliable releases, we need automated tests. And for having automated tests, we have different types of them. So we will have a ton of unit tests that will test isolated components of our applications, and we'll have very, very many of them because we want to test every possible use case. And then we're going to have the integration test based on top of that. And they would test systems where different components are in use at the same time. And those would be harder to write and then create, and then they will be harder to maintain. And then at the very top, we would have a few maybe user flow oriented end-to-end tests just to check that everything works well. And those will be executed somewhere in an environment that is similar to our production systems. So that was a long time ago, right? That was back then. And then eventually and when I say we, I mean the industry, we figured out that maybe in the current realities, this is not such a great idea. And a few years back, the engineering team at Spotify came up with a blog post about how they organize the testing of their systems, right? And well, mostly nowadays people do a lot of microservices, and this is specifically the approach that works well when you have a ton of components that don't excel at having a lot of business logic in themselves, but they are integrated in the larger system. So we will have a much smaller amount of implementation detail tests, and they will test something that is actually, well, the business logic. They're excellent when you're writing a compiler or like something with data transformations or a library. But then when you talk about the actual applications that we're writing, the main amount of tests that we want to have are integration tests, because the main complexity of deployments and actually having working software comes from having the software working correctly with other third-party components. Because, well, if you take one microservice, it probably does a little bit of something, but then it talks to databases, it talks to, I don't know, the message brokers, there is somewhere Kafka, then there are other dependencies like cloud technologies and the Elasticsearch and whatnot. So the base, we're going to build our test suite, automated test suite, based on the assumption that we want to have as much as possible integration tests, because they will verify also the low-level implementation details on the paths that they actually touch, but they will also work in the proper environment. And then on top of that, we'll have also, if we want, integrated tests that we will run in the more production-like environments. So integration tests are important, cool, and very modern. My name is Oleg Selajev, and I work at AtomicJar as a developer advocate, and you can find me online if you want. If you don't get to ask questions here, because we run out of time, I'm always open to some internet chatting. That's kind of part of the job description. Right, how do we want to do integration tests? And what does it even mean to have an integration test which isn't testing a component in isolation, but also isn't testing the whole deployment of our systems? Because imagine we are developing this red bubble there, and it depends on other services, on the service dependencies, on the green, brown, and other things. So to correctly test whether our red bubble does what it needs to do, we need to create an environment that encapsulates and we can run it. So we need to spin up all the dependencies there, which is kind of impossible very often. Because first, this graph of dependencies can go very, very much longer, because if there are any other microservices that we're developing or any other services, they might need their service dependencies and whatnot. And there also could be cycles. And also it could be infeasible to do on a developer's machine or infeasible to do in the small CI workers that you have. So it's very, very hard to do. So instead of spinning out the whole system here, what we want to do, we want to limit it by one level of the service dependencies we're going to spin up. So we're going to just go one level deep, and we're going to use the doubles instead of spinning out the actual production services. If those service dependencies are stock software, for example, a database or Kafka, very good. We can spin up actual version of the database that we're using, or Kafka, or Elasticsearch, or whatever you want to use, and actually use that in test. If those services are actually third-party APIs or other microservices that some other team at your company develops, we will create and spin up the mocks on the service level, and then we're going to verify them with contract tests. So we're going to have a mock, and we're going to test against that mock. And then we're going to give that mock to the other team and say, like, this is what we expect from you. This is our contract. And you deal with that, whether that contract is correct or not. This allows us a very important thing, actually two things. First, it limits our environment to what we actually can spin up reasonably on a reasonably powerful machine, whether it's your developer workstation or somewhere like in the CI. Second, it also limits us to the failures in the test that we actually care about, because we don't care about the failures that come from something in third-party systems that we actually don't develop right now. We want our test to fail only in case where our application that we are working on doesn't do something correctly. So we limit the environment, and then we spin it up for the integration tests. How do you do that? Obviously, we do that with Docker, because, well, who doesn't use Docker? And, well, currently many people might not want to use Docker, but it's also a very excellent piece of software. And it excels at two things. First, it excels at giving us the ability to run software and give it to other people to run software the same way as we do. And the dual of that is also possible, and it's very clear, is that we can take other people's software and run it without actually thinking how we need to run that software. And that second use case, when we run other people's software, is exactly what we need for the integration testing, because we want to have a unified way to create any applications that we need, databases, whatever. We need to want to run them in the same way in our integration tests. And of course, we're going to do that with Docker. And Docker is excellent for that. It works on all operating systems, so your developers will be covered, and it works in your CI, and it gives you process isolation, and it gives you API to actually manage the life cycle of those services, and gives the ability to configure them and everything. But Docker is also not excellent for integration tests, because very often it is not flexible enough. Because in an integration test, we don't just spin the services once. We want to have a fine-grained control over the isolation level. Maybe we want to have a database for every test case that we have. Maybe we want to have the database for like a few classes or every given class. But the thing is, we want to spin up the services and configure them for the test use cases dynamically, which is very, very hard to do with just running command line commands with Docker run or through YAML configuration. Besides just running the services, we want to have a total control over how we run them, which means we want to configure them on the fly. We want to configure not just what they do, but how they react to the other things. Like, for example, very often we want to include some case engineering practices in there and see because tests deal not just with the happy path, right? In your tests, you deal with all kinds of scenarios. What happens when data gets broken? What happens if I overflow my Kafka topics with millions of messages? What happens if my mailing servers start like spamming each other because the recipient is not found? And like, does the system go to halt or not? We need to have that flexibility, and unfortunately, Docker API, common ways to run Docker is not particularly enough for that. And that's where we welcome Testcontainers. Testcontainers is a collection of libraries that on one hand integrate with the Docker API and allow you to have this programmatic flexible control over how you run your service dependencies. And on the other hand, we integrate with your testing and application frameworks, so you can seamlessly use your Docker containers from within your favorite application code, right? Or from your test code, which is really, really great because it does two things. It merges your environment configuration with your code, which means it will never get in desync and it will never rot because it's actually the code that you do. And second, the whole configuration for the environment is in the programming language that you know and love and use anyhow, which is wonderful. It's a great project. It's an open source project. It started 7 years ago. We had a birthday, I think, last week. So congrats us. Yay! It uses the Docker Java API. The Java version uses the Docker Java API. And besides just exposing the Docker Java API to you, it does a lot of kind of sort of boring task automation that you don't want to do yourself. Besides just giving you abilities to say, oh, run that container. Testcontainers takes on itself the automatic cleanup of all the resources, because if your tests finish, you want to actually stop running the containers. If your tests actually error somehow and finish early, abruptly, you want to still do the cleanup. You want to have the automatic environment discovery and have the nice API for the configuration. So it's a great project. If you use Java, you should absolutely look at that. If you don't use Java, you should still look at that. We have libraries contributed by the community in all other popular languages. Go, we have Node.js, we have Python, we have .NET version, 3 actually, but we're trying to create one of. That is to rule all the .NET. We have Testcontainers Rust, if you're into Rust. So it's a very, it became a very popular approach to how to organize your integration tests. And it spun this collection of libraries in other languages, which is a testament to that the idea makes sense. And it's not just me, it's not just us. Just very recently, the ThoughtWorks tech radar put Testcontainers into the adopt category, which is very few projects actually get to be in the adopt category. And they said also very nice things about how this could be a default option for reliable environment creation for tests and all those nice words. So it's not just me, actually people are using that. So if you're not using Testcontainers, you should look into it. It's a very popular project. It runs, powers a ton of builds, and not just CI builds cranking out numbers, which very often can be the case, but we also see those stats are from Maven Central. We also see that individual IPs, so different people are using, and that chart is also growing, and currently at over 1 million a month, which is pretty interesting. And the cloud CIs always have the predefined IP ranges, so they cannot contribute that many unique IPs to the computation. Right. So hopefully we'll all agree that Testcontainers is a good project to check it out. So I'm going to show you a little demo of how it can be implemented, how it could be used in a Java application. We're going to do a very small Spring-based application, and it's going to do the following. There will be the conference talks, and there will be the ratings, and the application allows you to submit ratings to certain talks, which is a very sample application with a model of one Java record, which is a sample, but it also is a very enterprise application in a sense that it uses a database to store the talks information, and it uses Kafka to have the communication between two different components of the same application, and also uses Redis as a separate key value store, which I understand it's an overkill for such a small yet essential application, but it is a good sample because we will have to write the tests that actually create and use the environment that has those 3 things spin up for us automatically. So let's go to the IDE. Let's go to the IDE, and here we can see my demo application. It's just a Spring application, right? Very small. I cannot even run it on my machine currently right now because I don't have my database. I don't have anything. But this is exactly what we had there. We have a rating controller that binds that rating, and it uses Kafka, and it uses some repositories that uses Redis, and it uses some another repository that uses JDBC template. So you can see this is an actual application that will be using all those important technologies that you and I use in daily work for this example. We also have the test suite that I want to run and want to show you. Show and run, right? All good. There are a number of tests, and I'm going to run them now, actually, because I want you to see that they will fail. Right? So they will all fail Why are they failing? Because there is no environment to run my application, so it cannot do anything. So I cannot check anything. I cannot check that my context loads or any data exists in my database. My health endpoint returns something other than 200 because it will say like, oh, my database is not up. I cannot return 200. And there is even tests that actually use the functionality of the app, and they are like, oh, that's gonna hit the ratings with some sample values for a given talk, and then wait until it propagates and gets back to us on a different endpoint to see how application works. So it's a fully featured test suite. I even have the one test that actually does the negative thing and tests that 4 that something is not found. Which is, yeah, so, and it fails. So now we're gonna make this test pass, and we're gonna use the 10 minutes that we left from the session to do that. So we need 3 components here, and of course, the first thing that I need to do, I need to import the dependencies, and I've already done so. So I have my Testcontainers Kafka module imported because we were gonna use Kafka. We have Testcontainers Postgres available for us as a dependency, and we also brought in the JUnit integration just for fun of it. So now we're gonna go to the abstract integration test, and we're gonna create our first dependency that we want to run in a Docker. That's gonna be, what do you think it's gonna be? Kafka? Redis? Let's do Redis. We're gonna create a static field here, and the most important API that you need to know about Testcontainers is the generic container. We're gonna call it Redis, just for the fun of it, and we're gonna say new generic container. We need to give a Docker name for the container, for the image name that we want to run. That's gonna be Redis, and we're gonna give a tag. I think Alpine are the small images. That's it. This one line here shows us what the abstraction necessary to create the object that will be responsible for this Redis container. We can also configure this very, very naturally using our IDE. I don't know how to configure Redis because I know very little of Redis, but my IDE knows a lot. I don't even know a lot about Docker containers. Well, I might not, but my IDE knows what API are available, so it offers me a number of things to configure. I can configure this container to run with a different command, or I can add files to the container, like maybe my config for the database, or I can run with different environment or anything. So in this case, what I need to do, I need to expose a port from within the Docker container because we want to access Redis from outside. So Redis binds internally at 6379, and I know that. But externally, and this is something that Testcontainers does, externally, this port will be mapped to random high-value port because we want no conflicts. Imagine if I need 2 Redises here, right? This would not work. It's very, very hard to do this, and if it would bind to the same port. So Testcontainers, of course, does the sensible thing and doesn't bind it. Now we can run this container, and we have the whole lifecycle API method on it. So we can, for example, start it or stop it. We're not going to do it right here, but it's a possibility. There is also the integrations with testing frameworks, as I showed you, the JUnit dependency. So if this would be a JUnit test, I could add, like, for example, a container annotation there from Testcontainers JUnit, and then the container, my actual Docker container lifecycle, will be bound by my JUnit test lifecycle, which is very, very cool and very convenient. But we're not going to do that now. Right, so we create the container, and we need to start it. So we're going to say, we're going to start the Redis, and we're going to join and wait for that. And now we need to configure our Spring application for this dynamically generated Redis. Because now our test will start our application, and then it will find out, aha, I need to run my container. And then it will run the container, it will map with dynamic configuration, and then the application needs somehow to know where the Redis is situated because, well, it's dynamic. So we're going to do this using this, and this is Spring specific, but it illustrates the idea. This is a special method which creates and gives you access to the registry that you can use for adding properties dynamically during the test. So I can do Spring Redis host, and I'm going to say just get the host from Redis. And I'm going to do the same with the port. and I'm going to do just first mapped port because I don't care. We expose just one port. So we just say, this is our Redis. This is all that I need to have fully functional Redis running in Docker in my application code. Let's do Kafka as well, right? We're going to do all three, and then we're going to run the tests and marvel how green they are. Because this is the only kind of happy moment in the developer's life when red tests become green. And then you take the next issue, and then you see red tests again, which is horrible. How many of you know how to run Kafka in a Docker? So no one? How many of you have heard of Kafka? How many of you use Kafka at work? Okay, so everyone's heard of Kafka. Approximately 1/3 uses Kafka at work, and no one knows how to run it in a Docker container. I will show you. Static Kafka container, Kafka equals new Kafka container. And we need to give it a Docker name, Docker image name. We're going to use another DSL. So we need the actual Docker image name. So we're going to do Confluent Inc. CP Kafka. And we give it a tag. Look, there is a DSL for everything, so I don't even need to remember what I need to type. I just need to remember the actual string values if I want. Right? So this is how you run Kafka in a Docker. You create a Kafka container, and it works. Well, we also need to start it, right? Kafka. Start the Kafka, and we need to configure it. How do we configure Kafka? We say Spring Kafka bootstrap servers. And we just do Kafka. See? And my IDE knows that I want bootstrap servers because, well, I'm just talking about Kafka and bootstrap servers here. So I just click enter. I don't even need to write the code myself. It's only possible because Kafka is a module in the Testcontainers kind of community. So somebody who actually knows how to run Kafka in Docker, and that there is like a ton of configuration required to do that. And there it could be external zookeepers or embedded zookeepers, and you need more configuration just to get it started. Somebody who actually understands how to do that has embedded this knowledge into this Kafka module, right? And you as an end user, as a developer who works and builds applications with Kafka, don't need to know all those pesky details, right? You can just say, like, give me Kafka in a Docker, and there is Kafka for you. And there is a bunch of modules there. Right? There are a module for every taste, right? There are a ton of databases, everything you want. Mongo, DB, Neo4j, Oracle. There is a ton of other modules. We have a Kubernetes module if you want to test like Kubernetes operators or anything like that. Toxic Proxy, RabbitMQ, or anything. Web drivers, anything that runs in Docker, you can run nicely like this. We also need to run the database, right? I forgot. We're going to use a third part of very magical user experience of Testcontainers is we're going to run using a certain integration with JDBC drivers. So I'm going to configure my Spring data source URL, which is the configuration property that tells my Spring where my database is. And usually you put a JDBC URL of your existing running database somewhere in that. It could be a application properties file or anything like that. But in general, it's this JDBC, and then you have the URL. We're going to instrument that with the TC prefix, Testcontainers. And then after that, we're going to just say what database we want. So we're going to do a Postgres, and we're going to use just a random Alpine tag. And then the values here, it doesn't matter, digit. Those values are the database name and the schema's names. But in a nutshell, wait, is it right? Looks a bit short, but might work. PostgreSQL, 14 Alpine. Yeah, I think we can rerun the test now. So now in 20 lines of code, we created the database, we created the Redis container, and we created the Kafka container. And it's all going to run all together here now, unless I mistyped something here. Spring data source URL. Excellent. So you can see what happens now. Testcontainers detected the Docker and figured out and connected to a Docker. And then it started pulling the images. And then we got the Rook is a very important component in the Testcontainers universe. What it does, it is responsible as the proper desk daemon responsible for cleaning up the resources, even if my application here dies, right? So we're going to download everything. We're going to start everything. Our Kafka is ready and starting. And our test will just finish in a second here. Come on, stop pulling the images. The images will be naturally cached on the second request there, so we're going to see a much faster execution, if you will. You can see all the tests are green now, and I can rerun this, and it should be much faster. It just so you get the actual proper experience. See, this time it doesn't pull any images, and it's still reasonably slow, but okay, it's fast. Right now it runs the test, and in a few seconds it's just gonna pass all the tests. So this is it. This is how you can easily create very complex environments for running your application integration tests. And you have a very similar approach. And the best of it, this is my best feature, right? You can actually configure anything that you need just from your IDE. And your IDE helps you on every step with the content assist, which is just fantastic. Right. So, of course, this was a very simple demo. And you actually have a much better control over anything that you want to do with test containers. You can create a much more complex topologies. If your containers need to see each other through the common network, you can have that. If you want to extend the lifecycle of your Docker containers beyond your test runs, you can do that with reusable containers. You have the API to create like all kinds of complex startup awaiting strategies. If you're writing your own modules, for example, not just when the database container port is open, but when the database actually ready to accept incoming connections and serve something, you can create images on the fly and access logs, send files back and forth, execute commands, and all that. So anything that you want to do, it's all available to you from your IDE, from your favorite programming language, which is pretty amazing. Now, the question is, if you don't have Docker, which is a fair question, because not everyone has, there are different Docker environments that work, and test containers is, well, sort of agnostic. It just uses Docker API, so anything that is Docker compatible will work with that. We tried it on several. For example, Minikube is a sort of the developer time Kubernetes cluster that spins up Kubernetes on your local machine, and then it can expose the Docker environment, and it works pretty well. And if you don't want to mess with your local environment at all, you can look into Testcontainers Cloud, which is a product currently in private beta by AtomicJar, where it's a sort of serverless backend for your containers running via the Testcontainers tests. So you can just, well, run only your unit tests on the machine, and the containers will spin up in the cloud, and it's going to be perfect. It's an amazing product. Not yet generally available, but amazing. Right. And besides that, there are all the resources online. It's an open source project, so go check it out. I'd be very happy if you have questions, and thank you for coming.